A dazzling discovery. Could this new planet redefine what we know about the universe? In a bold revelation, researchers have announced the discovery of a planet unlike any we've ever seen. NASA, renowned for pushing the boundaries of space exploration, has revealed that this planet is fascinating not only because of its unusual size and orbital position, but because it appears to emit light that seems artificial in nature. Could this be the beginning of a paradigm shift in how we understand the cosmos? Might this signal the presence of life or technology beyond Earth? As we explore NASA's latest findings, we may be inching closer to answers that could change everything. Back in 2007, NASA launched the Dawn spacecraft to investigate some of the solar system's most intriguing bodies. Equipped with 3 advanced ion engines, Dawn's mission began with a 14-month study of Vesta, the second-largest object in the asteroid belt. The data it transmitted back was unprecedented. Highly detailed images revealed Vesta's complex surface and deep geological history. Upon completing its study of Vesta, Dawn moved on to what many consider the most exciting phase of its journey, a close-up examination of the dwarf planet Ceres. Thanks to its ion propulsion system, Dawn was able to escape Vesta's gravity, something impossible with traditional chemical propulsion, and embark on the next leg of its mission. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt between Mars and Jupiter. With a diameter of approximately 950 kilometers, it held the title of the smallest dwarf planet in our solar system until its reclassification in 2006. What set Ceres apart, even before Dawn arrived, were its mysterious qualities. Scientists were eager to get high-resolution images of its surface, and when they did, they were stunned. Brilliant, reflective spots appear across the planet, especially in a massive crater named Decatur. These glowing patches triggered a wave of speculation. What were they made of? What could they mean? Before the Dawn mission, the best available images of Ceres were low-resolution photos from the Hubble Space Telescope. The opportunity for a close-up observation reignited excitement among astronomers and the public alike. Dawn's mission was not only to enhance our understanding of the solar system's formation, but also to investigate how water might play a role in shaping planetary bodies. The bright spots on Ceres, also observed on some other celestial bodies, are believed to be highly reflective materials, possibly salts left behind from evaporated water. This finding hinted at the possibility of cryovolcanism, a form of volcanic activity that involves the eruption of water or briny substances rather than molten rock. But what exactly are these glowing anomalies? Could they be signs of active geology, or perhaps something even more extraordinary? Ceres is distinct from most asteroids due to its unique size, composition, and potential subsurface water. While most asteroids are rocky, Ceres has a composition more akin to a comet, suggesting it holds clues to the early days of our solar system. After a 2-year transit, Dawn began its approach to Ceres in early 2015. As it closed in, the images grew sharper, revealing a world of craters and shadows, and those now iconic bright spots. The more we saw, the more questions emerged. Were we looking at ice glinting in the sunlight, or something else entirely? As scientists continue to study the phenomenon, theories range from mineral deposits to evidence of ongoing cryovolcanic activity. To the astonishment of many, further analysis revealed that the brightest spot, it wasn't just a single feature that drew attention, but a collection of distinct bright areas scattered across Ceres' surface. The leading explanation is that these are salt deposits left behind after water or brine sublimated. This indicates that Ceres either had, or may still have, geological processes capable of bringing liquid water or brine to the surface, where it rapidly evaporates in space, leaving behind highly reflective residues. Such findings have challenged earlier assumptions about Ceres, revealing a world far more dynamic and complex than previously thought. The potential presence of subsurface water or brine pockets could have significant implications for our understanding of the potential for life beyond Earth. Ceres is often described as an icy world with a rocky yet porous crust. Unlike most asteroids composed mainly of rock and metal, Ceres stands out due to its unique composition, a blend of water ice and hydrated minerals like clays and carbonates. This lower density structure suggests substantial reserves of water beneath the surface. Its outer layer is rocky but porous, trapping ice and other volatiles. giving Ceres more in common with a comet than a typical asteroid. Scientists believe that Ceres has a layered internal structure, featuring a rocky mantle encasing a water ice-rich core, which may account for up to half of the dwarf planet's volume. The mantle is likely a mixture of rock and briny liquid, surrounding a denser core possibly made of silicates. The existence of this water ice raises a possibility that Ceres once harbored liquid water, particularly if its core was heated by radioactive decay during its early formation. This internal complexity makes Ceres unique among its neighboring asteroids and fuels intriguing questions about its geological history and the role of water in shaping it. Adding to the mystery, the discovery of ammonia-bearing clays suggests that Ceres may have originated in the colder, outer regions of the solar system before migrating inward. Ammonia acts as an antifreeze, lowering the freezing point of water and making the existence of surface brines more feasible. These insights not only deepen our understanding of Ceres, but also offer clues about the evolution of icy bodies throughout the solar system. One of the most fascinating processes thought to occur on Ceres is cryovolcanism, a rare and exotic form of volcanic activity. Unlike Earth's volcanoes that erupt molten rock, cryovolcanoes release water, ammonia, or methane, substances that can remain fluid under extreme cold. On Ceres, cryovolcanic activity may allow salty water to reach the surface, where it quickly sublimates in a vacuum of space. This process leaves behind luminous salt deposits, responsible for mysterious bright spots captured by spacecraft. The most famous of these is located in a crater, specifically the highly reflective region known as Spot 5. This area has drawn considerable interest due to its brightness and observed fluctuations over time. These changes are thought to be caused by sublimation of water, suggesting that cryovolcanic activity may still be ongoing or occurred in the recent past. Beyond Spot 5, Ceres hosts numerous other bright spots, each with unique traits, scattered across the dwarf planet's surface. Their distribution suggests that cryovolcanism may be widespread on Ceres, further underscoring its active nature. This stands in stark contrast to earlier views of Ceres as a geologically dead world. As NASA's Dawn spacecraft continued to transmit high-resolution images, it revealed a surface riddled with craters and diverse geological features, each telling a different chapter in Ceres' story. The discovery of the phenomena has fundamentally transformed how scientists perceive this small yet remarkably active dwarf planet. With its icy composition and strong evidence of cryovolcanism, Ceres has emerged as one of the most intriguing worlds in the inner solar system. Ceres, a frozen relic no more. Recent findings are challenging long-standing theories and expert opinions about distant celestial bodies, particularly the dwarf planet Ceres. Once considered a cold and lifeless relic of the early solar system, Ceres is now viewed as a dynamic, evolving world. Among its most captivating features are the mysterious bright spots, especially those in the Acator crater. These spots continue to intrigue scientists, hinting at active geological processes, and possibly even the presence of subsurface liquid water. Studying Ceres goes far beyond understanding a single dwarf planet. By analyzing its internal composition, surface features, and enigmatic bright regions, researchers gain valuable insights into the behavior and formation of other icy bodies across the solar system. Materials found on Ceres, such as water ice, ammonia-rich clays, and salt deposits, could provide important clues about the chemical environments of similar objects both within and beyond our solar system. One of the most exciting possibilities is cryovolcanism, volcanic activity involving ice rather than molten rock. If confirmed, this would reshape how we understand geological activity on icy moons and dwarf planets, and even raise the possibility of such activity on exoplanets. Environments once deemed static and inhospitable may, in fact, be active and potentially capable of supporting complex processes, or even life. Could other distant worlds, long thought to be frozen and lifeless, actually harbor the conditions needed for life? NASA's Dawn mission has been instrumental in rewriting the narrative. The data it returned has transformed our understanding of how the solar system formed and evolved. Every new insight into Ceres adds another piece to the grand puzzle of planetary development. Today, Ceres is no longer a forgotten object in the asteroid belt. It's a beacon of scientific mystery and potential. Its surface, interior, and puzzling bright spots may one day hold the keys to understanding how planets form and evolve. The possibility of subsurface water, and by extension, life or the ingredients for life, remains a thrilling avenue of research. These findings continue to inspire scientists, astronomers, and space enthusiasts worldwide. As technology improves and new missions are planned, the future holds even greater promise. What was once the realm of science fiction, the idea of life on other planets, is rapidly becoming a topic of serious scientific inquiry. Could microbial life exist in water pockets beneath Ceres' surface? Could similar conditions exist on other icy moons? These are the questions that will drive the next era of space exploration. The Dawn mission may have ended, but its legacy lives on. Every transmission, image, and data set brings us closer to uncovering the secrets hidden beneath Ceres' icy crust. The bright spots, far from being a solved mystery, continue to raise questions and fuel exploration. Their widespread distribution across the surface suggests an underlying process, possibly involving salty or briny water, which can make Ceres a prime target for future missions. With each new breakthrough, we inch closer to understanding the intricate dynamics of this icy world. As future spacecraft, and perhaps even human explorers, venture deeper into the cosmos, Ceres will remain a landmark of scientific curiosity. From its reflective spots to its hidden depths, it reminds us just how much we have yet to learn. So, what are your thoughts on Ceres and its remarkable discoveries? Let us know in the comments. If you found this topic fascinating, be sure to like this video and subscribe for more updates on space missions and cutting-edge discoveries. Ceres may have started as a footnote in the solar system, but today, it stands as one of its most intriguing and promising mysteries.